there is only one opportunity for me present, so I will select this topic and see which I'm interested in. This is the source code I want to present to you. You are all programmer and professional, but in this source code, it will compute this values. Want to compute this value in a fast way, very fast. Fast inverse square root. This source code can be seen in some game. It's very compute very fast. If you are not need a very precision, so you can just use one iteration. This is a Newton iteration. It's many funny root in this method. For example, the tangent, the section, then the point. So if we want to get a good approximation of this root, we must have a good initial value approximation to this value. But this source code gives very good information at first, so it's very fast to get this precision value. It's like this. And a lot of people cannot interpret this value, this constant, because this is a magic value. They use this magic value in the game and get a very good initial value. This source code only can be used in IEEE single precision format, but for double precision has other constant. Here is I want to first draw the format of IEEE. As we know, the first is the sign symbol, and another is exponent, maybe 8 bits, and that is the value of the. For example, we can this is S, this is E, this is M. The value can be expressed as this. Because the first value must be 1, so we can omit it and use this value. And so it's a normalized value. But when we express infinity and 0, it has another expression. So in this topic, I will not talk about this. Just this value. So this can also used in integer format. For integer format, we can say that as we know, for this value, it must be positive. So this must be 0. Cannot be minus. So which is not constant this. And this value is expressed as this. If this is the integer expression, the value can be expressed as it has a base of 127. M is equal to the upper M is this value in integer format and unsigned, and L is for example is if this is the biggest number of this and minus 1 is maybe the bigger value is this. So M is bigger than 0 and 1. This is normalize the M. By this, we can express the value here. This attribute for normalized expression. So how can we compute this value? First, we can know this symbol. Log in x. When x is very small or more than 1, it can express as this. and this is some value we don't know on the explanation. So we can derive our formats. And the first is that y is equal to this. So
excuse me. Therefore, you said that x is equal to 1 plus x plus 6.
this
Yeah.
this is okay. The
One.
first step approximation. If x is very small, it can use this to get approximation. But if we have this correction term, it may have good approximation. This is the central idea of this algorithm. Give a good approximation. Some values. So we can say that by this is x, well, y, the next step is we substitute ex and mx or ey my by this value. This is integer expression. So we need to use the integer because the integer is very fast format. So I substitute all this to this value to save time. I will drag the result. Substitute this value here, we can get these values. This value is interpretation of this to equal this. So we can get this value. This is the integer fraction of this float value. If you have get an integer expression, it will get this. For example, can this is expression atom and it has this shift. So we multiply this L and plus these values to get the integer value. And the fast algorithm is just derived as this. So this can, so we must, for this value, I mean, the R, this is very important to get the R. So they give the value of some constant as this. And to get the good, to use this good constant, because here this is the constant. This is constant, and we need also approximate this, and this value is this value is I don't know how to spell English alphabet. Do you know this? Epsilon.
That's sigma.
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 Sigma. Okay. This sigma value. So the sigma value is 0. Is this value? So our substitute you get R, and the R value we can give. How this value derived? First, the author has developed a training function, but after get result, it's not like this. It's not value, and he used then he used brute force search, and to determine which is good, also around the initial value. After that, he searched this with approximation, and here can explain why this value constant like this. And this value just as this value and minus this, and we also get this, and then use the Newton iteration algorithm to get the root, just as said at the beginning. I have a reference many paper and want to get why they get this value. I think this value called magic. Even today, no one know how the author developed this value. So I'm also curious about this, but I think I will, if I have interesting, I will proceed on this and present all the training function. The first training function used to gather some approximation, and after get this and this value, the first I have tested this algorithm. It's short, fast, very fast, and get a precision. But I want to say his value is maybe only valid for some range. I mean, only for this expression, but for other value, it's not very good. So it's a local algorithm, I think. But what I want to say is that this algorithm is surely very useful in game development. For example, you need fast, as I said, in the game development, you want to compute the light and some light and so. And first, you must normalize the vector. But if you use the normal algorithm, it will be very slow. But use the algorithm very fast and get a good precision and have a good effect. In fact, a lot of authors, they are not doing research, but in engineer application, but they are very smart and get a very good something. Maybe they are not present, but surely it's this. So I just present this algorithm, and if you are all interested, I will also pursue this constant.
Yeah, that number that you said that is magic.
Okay.
Yeah. How does found this number? Who found it?
This
Yeah.
number?
Yes.
This number is, I just say this number is, they use some training function to get this value. And at first it's not this number. He brute force around this number to get, he tests the time and the precision, then get this good number.
You mean that it is tested for the finding that equation and
Yeah, I think he made some function and
just exhausted
yeah,
search and found this number.
Yeah, I think that this is a Newton algorithm. We all know. It's like this. We also learned in numerical number analysis. numerical analysis.
Numerical analysis.
Yeah, Newton method. This is better than Eckhart method. I'm so nervous. I think it's very interesting. If you're interested, we can pursue this. Yeah. Any other questions?
Maybe we get one example.
Give you an example.
Yeah, for example, x is equal to, I don't know how.
One question before that, sorry. You suddenly have I y equal to e y equals to e.
This.
Yeah.
Oh, this must. I want to say same time. If you submit this value to algorithm and rewind, you get this.
But you don't have any I.
Oh, you mean this?
Yeah.
Oh, sorry. For this value, I want to explain. I is equal to it's the integer expression of this integer expression. For example, this has so many base, so it's multiply base and this part get this value. It's the integer expression of this net. It also has this is a float expression. This is integer float expression.
For example, if I is equal to 20.
20.
Yeah. What is E, L, and Y?
Y. Y is to I.
No, I.
I.
Yeah.
You want to use this expression?
Yeah. What's the meaning of I? Can you explain it again? I is equal to E.
And
E, yes.
E is the value of the
Oh,
power.
this is I say this is the normalized expression. I mean, you can integrate this. You know this.
Yeah.
This is this format, so floating. This is the integer. We constantly to convert the float to integer. But why they use this? It's because integer computation is very fast, not floating computation. So it just convert it to the integer expression, and for the same operation, so it's get very fast, get the initial value. This is the call of the
And what is big R?
R.
Yeah.
R is this.
Okay.
B. This is this value. The B is the base. Just rearrange it to get this. Oh, I want to add up something. This is a normalized expression, but it also has non-normalized expression. It's the attribute 22 expression. I can only express, for example, it can only express in this integer is range from 1 to 254. So by minus this constant b, it will get this value. So it can only express this range numbers. But one thing is that when this is this cannot express zero because this can never be zero. So how can it express zero is that when this value is equal, all of this value is equal zero, it can express some number as zero. But when this number is another is 25, this is normalized expression of this flow map. When it's 25, this value, when this value is zero, it's expressed infinity. When this is not zero, sorry, this is all one. When this is all zero, it expresses infinity. with this some bit is not 0, it implies not a number, NaN. So in either this situation, it's not applied in this. Whatever, this cannot be 0, cannot infinity, cannot NaN. So it's not this format. Yeah. Any other questions? Oh, you can, this soft code you can search in the web, you can test. It's surely fast. It's magic, I think. Yes, I don't know. It's not optimization in the register level, but maybe has a register.
What is the tree house? What's that?
This,
No, the first, yeah, one.
this,
Yeah.
oh, this is constant.
Why you use that one?
So this one, 3 over 2.
It's 2 or 4.
Yeah, 3 over 2. Yeah, this is constant.
1.5. Yes, that's one.
So yes, I don't know who do the computer optimization. When I was a grad student, and I internship in an international company, and my partner do optimization. What he always do is that always convert floating to integer. This is what she always do this. So when I saw source code, I remember her. It will save a lot of time if you know the architecture of CPU well. It's surely it's very good. But I think the core is defines this value. But for double precision, it also explores some constant value. But he didn't publish some of his code, say code. I don't know. Maybe some didn't.